Last new stuff for Unit 1. Oh my God, we made it. This is a long unit. This is day 13 of Unit 1. Today we're going to be talking about sequences and series and summations and recursion. There's a lot of stuff going on in this video. So you could be here for a while. You get to hang out with me. Whatever. By the way, all of these videos can be nicely, easily organized at www.nkinfinity.com. nkinfinity.com. That's where you can find all of these videos. N stands for Newman. That's my partner in crime. I have a new partner in crime this year. And K stands for Krause. And oh yeah, baby, an infinite amount of math just keeps spewing out of my mouth. Hope you enjoy it. For the next few minutes, you can call me Mr. Key. So instead of Mr. K, Mr. Key. Yeah, it doesn't matter. Same thing. All right. Use your knowledge of functions and a calculator. Do we really need a calculator for this? I should probably get my calculator available. The calculator we use, if you haven't been watching these videos, where is it? I sort of lost it. There it is the TI Inspire. It's a really, really cool calculator, and it's easy to find. You go to nkinfinity.com and you look for teacher resources. I'm not sure. I forgot what I call it. But you'll find the TI Inspire. It's on there. It's real simple to find. And there's a link on how to get the calculator for Amazon. Kind of cheap. Sort of. It's $120. I know that's expensive. But if you think about it over 6 years, I'm talking about college years too, it's like $20 a year. There's also a way to get it for $27 a year. So you decide. All right, so we're going to do f of 2. I'm going to use the calculator to check it because I don't really think I need my calculator to this one. I'm going to plug in 2. Notice when I sub in using parentheses. Don't forget that. So this is 4 plus 12 minus 8. So that's 16 minus 8, which is 8. Now if I wanted to, over my calculator, the best way I like to do this one is to say, okay, the easiest way I like to do is take the 2 and just store it into x. Say, okay, I'm going to take 2 and I'm going to store it into x, and then I'm just going to type in that original function, x squared plus 6x minus 8. And you get 8. There it is. I'm done. All right, back to this. We're going to plug in 4. So a sub 4 is equal to 6 times 4 minus 2, which is just 22. I'm not going through that work. Sequences is a set of numbers that follow a particular rule or pattern. That's the word I wanted, pattern. That's pattern. It's kind of similar to a function. All right, you got 2 types. We got a finite site, finite, and infinite. So a finite sequence is a sequence finite just means it ends. It has a first and last term. You know where it's going to end. An infinite sequence doesn't have an end. Let me give you an example of a finite sequence. 2, 4, 6, 8. There's an example of a finite sequence of numbers. It ends. Let me give you an example of this does not end. No end. It's a sequence with no end. And 5, 10, 15, and then you'd see dot, dot, dot. And it just has an end. It just keeps going. Now, there's a rule that defines it, but it doesn't have an end. So a rule for a sequence is really just an equation. But we use this terminology. A sub n is equal to, this is just an example. A sub n is equal to 3n plus 5. It's similar to function notation, like I could write a sub a of n, right? But that's not how sequences are generally written. So they're generally written like this, and it's read, and this is read a sub n. But it's just a rule to define a series or a sequence of numbers, okay? So we're going to do that for the first 4 terms of this sequence. So I want a sub 1, a sub 2, a sub 3, and a sub 4. So I'm going to write the first 4 terms of this function or sequence. So a sub 1, I plug in a 1, I get 3 times 1 minus 7. That's negative 4. I plug in a 2, 3 times 2 minus 7 equals negative 1. 3 times 3 minus 7, 2. Oops. Yeah, no, that's right. 3 times 3. I'm losing my mind. 3 times 3. And the next one is 3 times 4 minus 7, and that would be 12 minus 7 is 5. Notice it's just going up by 3 every time, and that's your slope. By the way, if you wanted to, you certainly could put this function into your calculator and then go look at the table. And the table will explain to you, and you remember you hit Control T. I think I need an N there. Control T in order to get to the table. Remember, Control T toggles the table on and off. I can do the same thing with this. I would have to type in this in my graphing calculator if I wanted to. This form looks weird, doesn't it? But I want the first 4 terms. A sub 1, A sub 2, A sub 3, A sub 4. I know my A's look like 9s sometimes. Sometimes my 9s look like A's. So 2 plus 1 minus 1 times 3. Well, 1 minus 1 is 0, so that's just 2. And then this is going to be 2 plus 2 minus 1 times 3. 2 minus 1 is 1. 1 times 3 is 3. This is just 5. 2 plus 3 minus 1 times 3. That's 6. Plus 2 is 8. Notice it's just going up by 3 every time. Plus 4 minus 1 times 3. That's 9. 9 plus 2 is 11. So there's the first 4 numbers in that sequence. And probably since it's a set of numbers, what I probably ought to do at the end is actually just list it out as a set of numbers. Negative 4, oh my gosh, I have a hard time with 4s. Sometimes they come perfect, sometimes they're just awful. Negative 4, negative 1, 2, and 5, and end my curly brackets, and down here, 2, 5, 8, and 11. All right. Simple sequences. You shouldn't really ever get sequences wrong if they ever, I don't even know if we ever ask that sometimes, but if it is asked to be, you shouldn't really get it wrong because you can always use your calculator and graph it and just go to the table, see what the numbers are. So arithmetic sequences and series. In an arithmetic sequence, the difference of the consecutive terms is called the constant. That means it's the constant difference between each terms, and we call it the common difference. It's called the common difference. And you can find that common difference very, very simply by taking, we always use the D. D equals A sub 2 minus A sub 1. You can also do D equals A sub 3 minus A sub 2. Or D equals A sub 4 minus A sub 3. They always have to have the same difference. If it's an arithmetic sequence, the difference between the two terms has to be the same. So let's just take a look at these 3 examples I got here. Let's see what we got here. If this was true, then the common difference has to be the same. So this would be D equals negative 3 minus negative 5. Well, that's really plus. So negative 3 plus 5 would be 2. Let's keep checking. d equals -1 minus -3. Oh, that's plus 3. That'd be 2. Let me try one more. D equals 1 minus -1. That's really plus 1. That'd be 2. So notice that my common difference is always the same. And you could take a look at this. We're adding 2. We're adding 2. We're adding 2. We're adding 2. Common difference. Let's see what's going on here. The common difference would be, and yeah, you could have negative 27 minus 32. That's -5. And then we do it again. D equals 21 minus 27. That's -6. And then the next one would be D equals 17 minus 21. And that's negative. Nope. See how these aren't the same? So the answer here, by the way, was yes. It's an arithmetic sequence. Here is no. Let's see. 5 minus 3 is 2. 9 minus... I already jumped to the right answer. 9 minus 5 is 4. I can already say no because it has to be the same all the way through. You can't... Every time you do it, it has to be the same. Always come back too soon. I'm trying to drink my coffee, kids. Leave me alone. All right. So one of the things you're going to be asked to do is to be given a set of data. Can you write a rule that will describe all of the terms of that arithmetic sequence? Well, the first thing you got to do is decide even if it is an arithmetic sequence. Later on, we're going to talk about geometric sequences. Those are a little bit different. But if you have an arithmetic sequence of numbers, this is the formula we're going to be using right here. This is the formula we're going to be using. Now, a sub n, this just stands for any term. Any term. The nth term. Maybe I should say any term, but it's the nth term. This is the first term. N is just the number of the term we're on. And D is the common difference. And so n is just the number of the term we're on. Number of term we are on. Let me explain that. If I had a sub 1 equals 10, and a sub 2 equals 12, and a sub 3 equals 13. A sub 3 is 13, but at this point, n is equal to 3. At this point, n is equal to 2. At this point, n is equal to 1. Does that make sense? N is the number of the term we're on. A sub n, or a sub 3, or a sub 2, or a sub 1, that's the actual number that it is for that term. All right. So first thing we're going to do is see if we got a common difference. So D equals 9 minus 2. That's 7. D equals 16 minus 9. That's 7. And you could just check they're all going to be 7. So I know that D is equal to 7. I also need my first term. Well, a sub 1 is equal to 2. So I can write my arithmetic sequence right now. A sub n, that's just generic. That's like f of x. Remember, that's just or like y. It's like f of x. This is sequence notation. Is equal to a sub 1, which is 2, plus, remember I'm using this formula right up here, 2 plus n minus 1 times 7. Now you can actually leave it like that. But sometimes when it's a multiple choice answer, that's not going to be one of the answers. You're going to have to clean it up. So I could leave it like this. If they didn't give me any specifications, I can just leave it just like that. But oftentimes you'll see on the multiple choice they've distributed out. So we're going to distribute this 7. So 7n minus 7. So I get a sub n equals 7n minus 5. Oh, and then they want us to find a sub 19. All right, so a sub 19 is equal to a sub 1. Well, let's use our formula. First of all, we got our formula now. Our formula is a sub n equals 7n minus 5. Well, I want a sub 19. That means n is 19. So 7 times 19 minus 5. Let's see. 7 times 20 is 140, so this has to be 133 minus 5. So a sub 19 has to be 128. Let me just check my work. Yes, and you can, of course, use your calculator on that one. All right, so let's take a look at this one. 45, let me do a different color, green. 45 minus 57, well, that's negative 12. 33 minus 45, oh, that's negative 12. And if you look, it's going down 12, down 12, down 12, so D is equal to negative 12. A sub 1 is equal to 57. I've got everything I need now in order to write the arithmetic sequence. So A sub n is equal to 57 plus n minus 1 times negative 12. And again, you could leave it like that, but I'm telling you, most times they're going to ask you to clean it up. So let me just clean it up. A sub n is equal to 57 minus 12n plus 12. Remember, we're going to distribute this negative. So I get a sub n is equal to negative 12n plus 69. All right, and they want to know what a sub 19 is. So I'll just do that real quick. A sub 19 is equal to negative 12 times 19 plus 69. I have no idea what that is. So I'll come over to my calculator. Negative 12 times 19 plus 69. And I get negative 159. Ka-ching. All right, keep moving on. You try. So at this point, you should probably be pausing the video. I'll take a little coffee break. My Dunkin' Donuts coffee. And you should be trying these on your own. I'll wait. I'll wait. I'm waiting. So I hope when you did this, you found out the common difference. The D was equal to 5 minus 9 is 4. Ooh, negative 4. Or the D is equal to 1 minus 5, which is negative 4. So D is equal to negative 4. And then a sub 1 is equal to 9. So my equation is a sub n equals 9 plus n minus 1 times negative 4. Now I said before you can leave it like that. Sure, let's leave it like that. That's it. It's done. Now I still want to find out what a sub 19 is. So that's 9 plus 19 minus 1 times negative 4. Not really sure what that is, so 9 plus parentheses 18 parentheses, that's 19 minus 1 times negative 4. Negative 63. So a sub 19 is equal to negative 63. Hopefully you got that one right. We got one more of these type. Let's see. So you got to be careful with your common difference. Notice it's getting bigger, and it's getting bigger, and it's getting bigger. So if you did this work, you'd find out that D is equal to 6. And then my a sub 1 is equal to negative 15. So my formula or my equation is a sub n equals a sub 1 plus n minus 1 times D. Or in other words, a sub n is equal to negative 15 plus n minus 1 times 6. I'm going to distribute this one. A sub n equals negative 15 plus 6n minus 6. Distribute to 6. So I get a sub n is equal to negative 15. Oops, what am I doing? 6n minus 21. And I got to find a sub 19. So let me do that real quick. A sub 19 is equal to 6 times 19 minus 21. So 6 times 19 is 114 minus 21 would be 93. That's it, kids. I could have used my calculator. I chose not to. I used the brainage. So now we got a little bit of a different kind of a thing. It says one term of an arithmetic sequence is a sub 11 is equal to 41. Well, this information tells us that n equals 11. We also know that the common difference is 5. Common difference 5. So let me write this formula down. A sub n equals a sub 1 plus n minus 1 times d. Now let's see what we know. We know d. We know n. Now n's 11. That means that a sub 11 must be 41. So I'm going to plug those pieces in. 41 is equal to a sub 1 plus 11 minus 1 times 5. So 41 is equal to a sub 1 plus 50. Subtract 50, I get negative 9 equals a sub 1. Now I can write my answer. My answer is a sub n is equal to negative 9 plus n minus 1 times 5. And you could clean that up. If you clean it up, you get 5n minus 14. But that's good enough. So here we go again. Let's try another one. A sub 15 is equal to 107. That means n is equal to 15. Because whatever is down here is n. So let's write it. Oh, and the d is 12. So a sub n is equal to a sub 1 plus n minus 1 times d. Let's plug in what we know. We know d is 12. We know n is 15. And we also know a sub 15, which goes over here, is 107. So 107 is equal to a sub 1 plus 15 minus 1 times 12. So this is 107 equals a sub 1 plus 14 times 12. 12 times 12 is 144, 168. Subtract 168, I get negative 61 is equal to a1, right? I get that right? Yeah. So my equation, or my final answer for this one, we'll do this in black, is a sub n is equal to negative 61 plus n minus 1 times 12. All right. That's all it is with sequences. Not too bad. Not too bad. You'll have some practice with that tonight. This thing here is called summation. It's the summation symbol. What we're going to do is I'm going to give you a rule, and we're going to add up the first however many digits of that series. Let's talk about what this thing is. On the bottom, you'll have something like n equals some number. This number is the starting number. All you'll have up here is some number. Well, this number, it's not the same as that number. This is the ending number. And here, whatever goes here is your sequence rule. Like we just created those rules. So let's see this first one. My start number is 3. My end number is 5, and here is my rule. Now, this big E stands for when you're done, add them all up. So I just like to do them right here. When k equals 3. So I get 2 minus 3 times 3. So that's negative 7. And then k equals 4. 2 minus 3 times 4. Let's see, 2 minus 12 is negative 10. And when k equals 5, I get 2 minus 3 times 5. 2 minus 15 is negative 13. And if I add all these up, I get negative 30. Because summation says add them all up, and that's what it is. All right, moving on. That's it. That's what summation means. All right, so this one's a little bit trickier. What I'm going to deal with first is this. Just this. So, n equals 0. So it's negative 2 times 0 plus 5. That's 5. N equals 1. Negative 2 times 1 plus 5. That's equal to 3. N equals 2. Negative 2 times 2 plus 5. That equals 1. N equals 3. Negative 2 times 3 plus 5. Negative 6 plus 5 equals negative 1. Now that says sum them all up. So if I sum all these up, I get 8. So in replace of this, it's really just an 8. Well, what was before it? 4 times and plus 7. So 7 plus 4 times what we came up with. 4 times 8 is 32. 32 plus 7 is 39. All right. So again, we're going to take care of the summation thing first, and then we'll deal with the 3 plus it later. So we got k equals 4. That's our first number. K equals 5. K equals 6. And k equals 7. So it says k minus 6. 4 minus 6. Negative 2. 4 minus... Oh, crap. It's k minus 6. So 5 minus 6. 5 minus 6. That's equal to negative 1. 1. 6 minus 6, that's 0. 7 minus 6, that's 1. If I add all this up, I get negative 2. Because these cancel, and I end up with negative 2. So what do I have there is 3 plus negative 2, which is just 1. So that answer is 1. Now, I can use my calculator to check my answers. So let's see. Is that the first one we did? 3 to 5, 2. So we're going to check our answers real quick. And this graphing calculator, TI Inspire does things so nicely for us. Let me move this over here. Oh, I can't do that. You know what I'm going to do? I don't know what I'm going to do. So to get to that nice calculator, you go into this complicated button right here, and you click on it, and you find the summation thing. It's over here. It looks like that. Click on it. It looks like this. So let me go back and forth. K equals 3, so I'll put in K. It really doesn't matter what letter you use. K equals 3, but you should probably stay consistent. 3 to 5. And now I got to put the function in. The function is 2 minus 3K. 2 minus 3K. So whatever letter you use, you got to use it in both places. I click enter. It's negative 30. That's what I came up with. Let's try this next one. This next one was a little bit more complicated. Lots of kids made mistakes on this one. So we're going to go bink, dink. Now, first we should put in front 7 plus 4 times this thing. And then we can start putting the numbers in. What do we got? N equals 0. By the way, N is generally the most used one. Almost always N is used. We'll put N equals 0 in there. No, oops. N equals 0. And then we'll go up to the top. And it goes to 3. And on the right, we have negative 2n plus 5. Negative 2n plus 5. Hopefully this is 8. Hopefully it's negative 39. I'm not negative 39, positive 39. Yep. And so that's an easy check. I'm not going to check the last one. You can figure it out. It would work. All right. So, but you do have to do them by hand. Oftentimes they come up as you have to show work on your exam. So you want to make sure you do that. Otherwise, you might not get it right. Just throwing it in your calculator is not going to be good enough. All right. That's summations. All right. Let's do something about recursion. Anybody in computer science understands if you have recursive functions, that's one function calling another, which calls it back, which calls it back, which calls it back. So recursion is just doing something over and over and over again. You'll usually see it in either notation. I'll give you a first term, and I'll ask you about the previous term. Or I'll give you a first term, and I'll ask you about the next term. But it's always one term, and then something next, and then something next, and then something next, and then something next, okay? And Usually the starting value is, this should be a sub 0, I think. So this would be a sub 0. This would be the second term. This is a sub 1. This would be the term before it. Whatever. You'll see how we do this. So here's how it works. I give you the first term, and then I give you a rule. Okay? So a sub 1, and we're going to find the next 4 terms. So a sub 1 is given as -4. So we got to find 4 terms after that. So a sub 2. Now here n was equal to 1, but they just gave us this. This case n is equal to 2 because it's right there. So that's equal to a sub 2 minus 1 plus 5. Well, what is 2 minus 1? That's a sub 1 plus 5. Well, isn't this a sub 1? Yeah. So this really becomes just -4 plus 5, which is positive 1. So now n is 3. So now I'm going to do a sub 3 is equal to a sub 3 minus 1 plus 5. I'm just using this rule that I was given. But isn't 3 minus 1 2? So this is really a sub 2 plus 5. Well, isn't this a sub 2? So I'm just going to plug that in here. So I get 1 plus 5, which is 6. So you see how recursion uses the previous term to generate the next number in the sequence. So n equals 4 is really going to be, or n equals 4, so that's a sub 4 is really equal to a sub 3 plus 5. Well, a sub 3 is 6. 6 plus 5 is 11. And finally, n equals 5. A sub 5 is equal to a sub 4 plus 5. Well, a sub 4 is 11. 11 plus 5 is 16. So the answer would be 1, 6, 11, and 16. Hopefully that's not behind my big old schnoggin head. All right. Let's try a few more, and then I'll give you a couple examples. Then I'll give you a little practice. So I'm giving you a sub 0. A sub 0 is equal to 1. And I want the next 4 terms. So I want to do a sub 1, a sub 2, a sub 3, a sub 4. Well, this n minus 1 really says use the previous term. Because if n is equal to 1 here, 1 minus 1 is 0. Well, a sub 0 is just 1. So this is -1 plus 5 times the previous term. So this is -1 plus 5 is 4. Now it's going to be -1, because that's the rule, -1 plus 5 times the previous term. So that's 19. And then it's going to be -1 plus 5 times the previous term. Let's see, 5 times 19 is 95, minus 1 is 94. And then it's going to be -1 plus 5 times 94. 94, let's see. 5 times 94 should be 469? Yeah, 469. Sounds about right. All right. On the you try, you should pause it, and you try the next 2 on your own. Pause it, come back, we'll see how you did. All right, so I didn't want to show this to you before, but I'm going to show it to you now only because it's really cool. But we're going to do these by hand first. So a sub n is equal to 4, and I'm going to create the next 4 terms. So a sub 1, a sub 2, a sub 3, a sub 4. Let's see. 2 times the previous term, 4. That's 8. 2 times the previous term, that's 8, so that's 16. 2 times the previous term, that's 16, that's 32. 2 times the previous term, that's 32, that's 64. Now let me show you something cool on your calculator. I'll show you with the last one and then this one as well. So let's take that last one. So last one started out with 1. So we're just going to put a 1 in. Now 1 is stored in answer. Do you see this thing in blue right here? If I just do control answer, it's 1. So here's how it works. We're going to do negative 1 plus 5 times the answer, because the answer was the term before it. 4. Oh, 4. 19. Oh, 19. Next one should be 94. 94. Next one should be 469. 469. I can do the same thing on this one. This calculator is great and really nice for recursion. Plug in 4. That's our first term. We're going to do 2 times our previous term. So 2 times answer. 8, 16, 32, 64, 128, 256, blah, blah, blah. Now don't do that. Now, I just showed that to you and you can't do it on this one. It doesn't work when they put n in there. It only works if you're just going to use the previous term. It doesn't work otherwise. So a sub 0 is equal to 3. This one's going to be a little bit trickier, kids. So now n is equal to 1, n is equal to 2, n is equal to 3, and n is equal to 4. Those are the next 4 terms. So a sub 1, a sub 2, a sub 3, and a sub 4. You'll see why I put the n's there in just a second. So it says take the previous term, 3, and subtract off n squared. Well, n squared is 1. Well, n is 1, so this would be 1 squared. So it would be 3 minus 1, which is 2. And then it says take the previous term and subtract off n squared. Well, n in this case is 2, so 2 squared. So this would be 2 minus 4, which would be negative 2. Then it says take the previous term, negative 2, and subtract off n squared. Subtract off 3 squared. So negative 2 minus 9 is negative 11. And then it says take the previous term, negative 11, subtract off n squared. 11 minus 16 is negative 27. There she goes. All right, we got a little bit of practice. So, again, pause it and try these on your own and see how you do. I'm waiting. No, really, I'm waiting. Oh, you're back. Hey, how you doing? So I want to do the first 6 terms. So a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and then a sub 6. Now you should see a pattern after a while and get this. So 1 would be 1 plus 2, which is 3. 2 would be 2 plus 2, which is 4. 3 would be 3 plus 2, which is 5. And obviously this would be 6, 7, and 8. There they are. Write the first 6 terms for this one. So a sub 1 is 1 squared, or 1. A sub 2 is 2 squared, or 4. A sub 3 is 3 squared, or 9. Do you get it? A sub 4 is 16. A sub 5 is 25. And a sub 6 is 36. Write the first 6 terms of this sequence. All right, so let's see. A sub 1 is equal to 4 times 1 minus 1. 1 minus 1 is 0. 4 times 0 is 0. A sub 2 is equal to 4 times 2 minus 1. And that would be 4. And then a sub 3 is equal to 4 times 3 minus 1. That would be 8. And then a sub 4 is equal to 4 times 4 minus 1. 4 minus 1 is 3, so this would be 12. So it looks like we're adding 4 every time. A sub 5 is equal to 4 times 5 minus 1. That would be 16. And of course the last one is just 20. This one's actually easier. Write the first 6 terms. So when n equals 1, it's 3 over 1, or 3. When n equals 2, it's 3 over 2. When n equals 3, it's 3 over 3. 3 over 3 is 1. When n equals 4, it's 3 over 4. When n equals 5, it's 3 over 5. And when n equals 6, it's really 3 over 6, but that's 1/2. And this one was really 3 over 3, right here. All right, find the 10th term of the sequence. We just plug 10 in. So a sub 10 is equal to, I've been given the rule, 2 times 10 over 10 plus 2. So that's 20 over 12. Now you could leave it like that, but 4 goes into all of them, both of them, so 5/3. Doesn't matter. Evaluate. So remember, when we do this, we're going to do this first. So let's get this first. It's going to be 2 times something. All right, so 3 squared is 9. 4 squared is 16. 5 squared is 25. And 6 squared is 36. Let's see if I add all this up. This is 15 and 25 is 40, 76. So this becomes 2 times 76. It's 152. Let me check my work. I have 86. What am I doing? Oh. All right, when I add all this up, let's see, this is 15 and... No, it's not 15, it's 25. I got 15. 25 and 25 is 50 plus 3 is 86. So it's 2 times 86, which is 172. I should have used a calculator. All right, so my first term is negative 6. So it's going to be absolute value of negative 6 plus 8. And that's equal to the absolute value of 2, which is equal to 2. Then we're going to do negative 5. Notice it starts at negative 6 and goes to negative 4. So negative 5 plus 8, that's the absolute value of 3, which is just 3. And finally, negative 4 plus 8 is equal to the absolute value of 4, which is just 4. And if I add all that up, I get 9. Hey, that's it. That's all you got to know, all 14 days for the test. There will be a review packet, probably a practice test for you all. It'll be quite comprehensive, but that's it. That's all there is. I hope you guys do well. Study, study, study. Another thing that we're going to be adding pretty soon is flashcards. And there'll be some notes in my other videos. We're going to be adding some flashcards for you to study, but I'll have to put those in my other notes. All right, kids. Catch you on the flip side. Bye. Oh, hit subscribe. Hit the like button. Let me know what you think.